Hi, Nicole. This is problem 6.5, and the answer should be 1.5 a naught. So we're going to see if, so 1.5 is 3 over 2, right? So we're going to try and see if we can get 3 over 2 times a naught. Now, they want the average value or the expectation value of r. And to get that, you do the integral over all space of r times the probability of r dr. Now, all space is 0 to infinity because we're using some kind of radial coordinates here. So r being radius, so the radius is distance from the center. So we don't care about negative infinity because that would just be the same space. We're doing r here, some kind of circular type of coordinate system. I don't know if it's circular or what, but it's not linear, so we don't have to go negative infinity to infinity. Anyways, that's what this is. So this is p of r here. This right here, all that is p of r, the probability of r. Where did I get that? That was equation 626 over here. That was equation 626 right here. So I just copied that and put it right next to the r. The integral of r, and then equation 626, which is p of r, and dr. All right? So now that is what we are going for. So let me just put the constants outside. Right? So this is going to be 4 pi n squared integral, and now recopying everything down, r e to the minus 2r over a naught dr. All right? Now, I'm done with the integral because in the problem they have given us that, they've given us this. In the problem they had said, they have just told us, oh, there's your fingernail job there. Nice stars. All right, so they have given us that this integral equals that. Now, this integral is what I actually have here. Let me just copy this and put it here. Right, so this integral, that's what I've got here. Instead of x, it's r, right? Oh, wait a minute. It's not just r here. Sorry about that. There's r and there's r squared. So it's r cubed here. So that's what I've got. I've got the 4 pi, the n squared, the r cubed, and the e to the power of negative stuff, and then dr. Okay, good. So the r is really the x. And the n is equal to 3. And the b, so this whole thing is, we can rewrite this as negative 2 over a naught r. So the b is negative 2 over a naught. I mean 2 over a naught, because the negative sign is already accounted for here. So b is 2 over a naught. So that means this integral is, the answer to this integral is n factorial, which is 3 factorial, over b, which is 2 over a naught, to the power of n plus 1, which is 3 plus 1, which is 4. Okay. So now, let me simplify this a little bit. So I've got the, I'll just leave this 4 here for now. 3 factorial is 6. And this is a fraction underneath the fraction bar, so this is really times the reciprocal of this, so a naught over 2, but this was to the 4th power. Okay, so this is, I'll copy this down again. Now 6 times a naught to the 4th over 2 to the 4th power is 16. So this is now a 4, this is a 1, and I can divide this by 2 and divide this by 2. So I end up with 3 halves. That's promising. That's what I wanted. Times pi n squared a naught to the 4th. All right. Now, I wanted this. I wanted 2 of these, but not 4 of those. And I didn't want this at all. So what do I do now? Well, what is this n, the normalization factor? You can calculate the normalization factor yourself by doing what they did right here in worked problem 6.5. To find the normalization constant, you use equation 626 over all values of r, and equate the result to 1. That's how you find normalization factors, normalization constants. So here it is. This is equation 626, the same one that we used, and you set it equal to 1. And when you set it equal to 1, you get this. And when you do the substitutions of this, so n is equal to, actually, is this the one that we want to use? This is for the 1s orbital. There n is equal to 2. Okay, so this n is not the same n as this one here. Okay, so this is the same one. We're going to use exactly the same thing. All right, so so this n is equal to 2, and the b is equal to 2 over a naught, and you end up with this. You just substitute this stuff in for this integral part, and you get this, and then you divide both sides by everything except for the n, and then you take the square root of both sides, and you get this. So n equals 1 over the square root of pi a naught cubed. But you see, we don't have n, we have n squared, right? So n squared is 1 over pi a naught cubed, right? So n squared is 1 over pi a naught cubed. So this goes in right there. So that means the average r is going to be equal to, copying things down and substituting this in for the n squared, 1 over pi a naught cubed, and then a naught to the 4th out here. This is gone, this is gone, and I end up with 3/2 a naught. So that is the average value of r, and that is what we wanted. There it is, 1.5 a naught. Very good.